No.
If you're clicking on this video, it's probably because you're trying to learn about prompt engineering. If you're curious of what prompt engineering is, and you happen to be a computer scientist, today I'm going to be talking all about it, specifically in how you could use it in projects to do some pretty cool things, some of which I'll demonstrate. Just an overview of prompt engineering. What? Okay, so just getting back to the overall topic of prompt engineering. Prompt engineering is essentially when you have some task that you want a language model to complete for you. In the context of computer science, these tasks tend to be usable in a program. So as kind of an example, one of the things I would use is, say you have some sort of question and answer that you want a language model to actually respond to you with. So you have a question and you have some number of answers. So you have 4 answers, A, B, C, D. One of the ways that us computer scientists would want to use something like that is to have the language model answer the question in natural language and then pick the best option as some sort of response. And the response is something that you could use inside of a program. At the high level, this might make sense, right? You want to be able to use outputs from a language model in a program. The thing is, though, not many people actually truly understand the power that you could implement a program behind prompting a language model, which is what we're going to do today. For more context, though, we're going to start by kind of reading over what prompt engineering is and just kind of talking about it a little bit more, because I feel like kind of having a good understanding of what the general definition of prompt engineering is will help us later actually perform this. So here it says prompt engineering is the process of structuring text that can be interpreted and understood by a generative AI model. A prompt is a natural language text describing the task that an AI should perform, which is a really good general description of what you can do with prompt engineering. And in most contexts, what this is kind of referring to is the fact that as just kind of a chatbot, she's kind of like a chatbot interface. You know, you could get a chatbot to respond to your questions and have it be correct, right? That's really good in the context of setting up some sort of chat into some, basically embedding a chat into a program. So you're running a business, and part of your business model depends on having some sort of chat interface that your customers can actually talk to. That's really useful for that one specific use case. But a lot of people kind of overlook the fact that not only can you get a chatbot to respond in a way that makes customers engage more with the product, that's kind of one specific area of prompt engineering. Focus and highlight powers specific to chat. Now, language models can do all sorts of things. We could see this kind of in recent implications that demonstrate that they're able to code, that they're able to solve complex problems, they're able to construct very large amounts of data. Say you have some sort of question. How do I do this? What is, I don't know, let's say a derivative. Say we're asking ChatGPT what a derivative is, right? What is a derivative? It's going to formulate a response that kind of generally answers what our question was, which is amazing, especially if you're trying to get information. But as a programmer, this kind of stuff is only useful for information, right? If I'm trying to learn something, this kind of tool is only at face value useful for helping me learn stuff. But what if I told you that there's another use case? Let's keep looking. So here you could see that prompt engineering may involve phrasing a query specific in a style that kind of mimics some sort of like question and answer, or here's input and here's output. And here they're kind of demonstrating that maybe maison gives you house and chat, and that gives you cat and chin, and that gives you dog, right? Act as a native French speaker. And these examples that you're providing a model are essentially what we call few-shot prompting. Few-shot prompting is really important. And essentially what it's saying is, hey, I have this small task or big task, any task. I'm going to provide you examples of how to do that task. Now, kind of copy what it is that I'm doing, and please do it for me. The power behind this, which you might be able to start to see, is you can now solve arbitrary problems with a language model. Here's another very interesting use case, which we call chain of thought. Essentially, the idea is you kind of reiterate what it is that you're telling the language model to do. Now, essentially what this is doing is, say I give you some math problem, and I ask you directly for the answer, and you just have that one prediction window of actually providing me the answer. Let's say the answer was 6. Chain of thought kind of builds on that. It's essentially saying, well, if I give you a question, I want you to take the question, I want you to think through it, and reason about what it is that I'm asking for. And then after you're done doing that, provide me the answer. And you could see that with this, right? For the example Q, the cafeteria has 23 apples. If they used 20 to make a lunch and bought 6 more, how many apples do they have left? Or how many apples do they have? Some example of chain of thought would be the cafeteria had 23 apples originally, and then they used 20 to make lunch. So now they must have 23 minus 20, which is equal to 3. Then they bought 6 more apples, so now they would have 3 plus 6, which is equal to 9. That means that our answer is 9. So you could kind of see how instead of directly shooting for the answer, which probably wouldn't work in the first place, it's reasoning through the logic of how to actually solve this problem. And this is really useful because it can let you allow language models to implement arbitrarily complex rules in order to solve the problems that you have. There's some other techniques here that are very useful, right? Like least to most prompting. Essentially ask it to break a problem down into the subproblems and then have it continue solving the original problem. There's all sorts of different methods that they propose here, including even tree of thought, which is a very useful one if you're looking to kind of find the best response or find the best answer for some question, a hard question that requires lots of reasoning. Now, through all of this, I would suggest something that this article doesn't do a good job of actually discussing the power of this. And we could kind of go through here. They talk about using gradient descent, prompt injection, right? This is kind of all getting along the lines of what high-level things can we do, as opposed to concretely, what can we use prompting for? And today, we're going to go through exactly what you could use prompting for and provide examples of how our team has used prompting in our projects. And after that, we're going to actually get into an example of how to use prompting in your project. So stay tuned. Okay, so this here is an example project that our team has worked on to go over the idea of prompting in order to solve arbitrarily complex problems. The problem that we took on was teaching a student, right? Teaching a student requires lots of data. Now, a lot of this data lives out on the internet. In fact, Khan Academy even has open source courses for anybody just to kind of take. But we didn't really want to tap into any of the open source or closed source data sources on the internet, specifically copyright. Copyright is really hard to come by, even though some of these models might be copywriting stuff out there. But besides the point, we didn't necessarily want to go the avenue of kind of installing in already created practice problems, already created learning resources. So we took on the task of creating those learning resources through prompt engineering. Well, this work kind of poses large language models to act in environments. If you're unfamiliar with what that means, that's okay. Essentially, it's just saying that they're going to operate on things over time and get to kind of see how their operations affect what it is that they're working on. You could think of this as if I was working on a windmill in technology class. So you start off with a bunch of wood, and over time you get to cut the wood, and when you cut the wood, you could see that the wood is cut. Same thing when you actually start piecing together the wood, you'll be able to understand that the pieces that you're putting together are forming some sort of shape, a windmill. It's really centered around the idea of there's information that you're going to use to build whatever it is that you want to build. That could be, in our case, right, we used the teaching documents, so like educational resources, so slides, questions. We expanded it a little bit more, but concepts, right? We want to find relationships between ideas. These were all things that we try to do using language models. And that brings me to cognitive processes. And this is kind of just an idea that we had while we were doing all of this. But essentially, it's building on the ideas put forth in a bunch of other papers and kind of trying to simplify it. There is a few papers out there like Generative Agents, Voyager, and some others that kind of implement language models to do stuff. In the Voyager paper, they actually got GPT-4 to play Minecraft, which is amazing. How do you get a language model to play Minecraft? Well, this kind of stuff that we're going to be talking about today might give you a better idea of how that even happened. So one of the places that we started was thinking about how you actually construct solutions to problems. And this is really hard, and we talk about this actually in our paper. But given that your problem is not that challenging of a problem to solve, and you could break it into subproblems, that lets you manually stitch together different prompts in order to solve whatever it was that you tried to start with. Essentially what I'm saying is this. If I have a challenging problem, let's say I want to solve some sort of exam, but I don't want to just kind of one-shot the exam, right? I could give the exam or a copy of the exam to ChatGPT and say, hey, solve all of these questions. And ChatGPT might be able to do it one shot, right? That's what we call one shot. I give you the problem, I ask for the solution, and you're supposed to solve it without necessarily implementing any other additional methods, like kind of like problem deconstruction, or I'm trying to think, like chain of thought. I mean, might be okay, but there's only so much you could kind of extract from a language model with one single prompt. So right now I want you to think about this. When you ask some language model to basically solve a problem that you have, or ask it for information regarding something, what is it doing? Well, it's just predicting text. And because it's just predicting text, it's limited to whatever prediction it has at each time step. So if it gets one thing, I wouldn't necessarily say bad. But if it gets unlucky in predicting text, then that unluckiness kind of builds over time. Think of it as if you only had one opportunity to solve a calculus problem. And you start off by differentiating, and you realize along the way that even though you did all of the differentiation right, the cancellation that you did wasn't the right cancellation. And now you're kind of stuck. And you don't necessarily know where to go. This is a problem that language models can fall into because you could think of that as just kind of executing one path towards your destination and falling into whatever choices you made immediately without really giving it much thought. And there's a few ways to combat this, which we kind of already discussed, like chain of thought or tree of thought. Tree of thought kind of lets it so that you could have multiple paths that you could go down, and that solves a lot of problems really well. Most math problems are actually solved very well using tree of thought. The problem with this is when the language model doesn't necessarily know where to start. If the language model doesn't know where to start, then it's just going to kind of go off in whatever direction it believes might be the best. And that is kind of where prompt engineering comes in. Say you have a complex problem that has already been solved by people, but now you're trying to get a language model to kind of use our solution to do it for us instead of actually doing it ourselves, like maybe translation or text conversion on the fly. Well, there's a thing, namely cognitive processes, which allow us to kind of build one after another to chain output from a language model into the input of another language model. You could think of this as kind of taking a block or a structure that you've originally built with the output of one language model and then embedding that into the prompt of another language model and asking it to use it as kind of like a workaround or like a tool. In our case, one of the things that we did was we would construct entire sequences of these things called slides, right? We're trying to build a presentation. But the presentation is in text format. It's not necessarily in a format which we could use in our program. So you could think of that as taking natural language text and then asking a language model to translate it into an object. The similar thing can be thought of for our planning stage. So one of the things that we have our language model doing is talking to the user. It's trying to get information from the user to extract what it is the user wants, namely, what kind of learning material is the user interested in engaging in, to what level does the user want to actually learn, and what's the user's motivation behind actually doing this, right? If you have a class that you need to study for, you have a completely different motivation for doing so than maybe a project. Maybe you're trying to learn how to use some idea, maybe it's like breath first search for some class project that you have to do, or a personal project that you have to do, or work project, and then maybe you also have no reason for learning it, just for your own sake of having fun. And these are all things that, you know, a language model can use to make other predictions down the line. But you need to be able to actually extract that information from text, which is what we use our method for doing as well. We plan how a language model is going to respond to a user while getting those pieces from the user. So essentially what we're doing is planning how we're going to extract information from the user, and then we actually engage in asking the user for the information. But the key thing is that we're engaging in an extra step in between. It's a step that the user doesn't get to see, and we call that the plan. The plan is essentially what we use to actually do the things with the user. You could think of a language model as an actor, right? It's just doing things, and it's doing things with the user to get more information, which we then use to make another plan, which we use to create an action that we use to do something with the user, which we get information back from the user to make another plan, and so on and so on. You see how this works? Maybe just kind of visually, it's very similar to this diagram where you have some information being presented to you and you're asked to plan and then act. They do it a little bit differently in here, namely because their problem set is a little bit more challenging and they have a little bit more complex structures going on. I don't really want to spend too long talking about what they did here, but you could think of this as over time you're developing a memory stream that lets you do certain things, whereas we are taking something in, we're planning, we're updating our memory stream, and then we're acting. And then that comes back in, we plan, we update our memory stream, and then we act. Just to go back to what we can do with our model, we're going to be talking about planning, translation, and discrimination. And hopefully this will start to make sense to you when I start kind of going over these things. Planning, also framed as information generation surrounding a problem, it provides us with this natural language insight into maneuvering some current place in a problem. We use it to plan how we're going to do one of a few things. And these might be filling out some data structure with information based on the context. Memory and planning used to reference something in the future or pull important information from the context that we're giving it. We may reason about how certain different actions might play out in the environment. You could think of this as thinking of whether or not to go left or right on the highway. Maybe if I go left, I'll get there maybe 5 or 10 minutes faster, but it's rush hour and there might be a lot of cars on the road, especially if we're taking the highway. So maybe taking the back roads or going right is the better idea, and then you might say, well, we should take the back roads because it's rush hour, and if we go left, then we might have to sit in traffic for a really long time. This all depends upon context. That's kind of the whole idea with this, is you're providing the model with context and you're asking it to plan or reason about what to do or what to focus on. Those ideas alone allow you to do a lot with information presented to a language model. The kind of information that we presented to a language model involves what the user's saying, what were the previous slides that you've created talking about, what kind of questions does the user want you to ask. These are all important things that you want to include in a context, and a context is dependent on the problem that you're trying to solve. That then brings us into translation. Translation is an idea that says language models are really good at pattern recognition, especially around language. You could think of this as taking natural language and converting it into code. Maybe Python, right? I want you to write a program that calculates prime numbers. The language model interprets that and then translates your natural language into a Python program, if it's a good language model. The idea with translation is it's going to implement whatever pattern it needs to from your input data into some output data. And the idea with this is you have to give it every detail it needs in order to perform the translation. That part is crucial. An example of this would be if I kind of lay out a bunch of slides or like a list of things, maybe like a grocery list, like apples, pears, croissants, etc., etc. The translation you might ask the language model to do is to organize these items into a JSON object, namely a JSON object with a field called grocery list that maps to a list. The idea with translation is you're taking data which you cannot use in a program and converting it into data that you can. Another really useful implementation for translation involves calling functions. Say you have a list of functions, all with specific names, all with different parameter types. And the context that your language model lives in is dependent on what function it's going to call. You can think of this as picking a object from the list of objects that you have and including the parameters that you might need. Let's say you have a speak function that you can call that lets the language model talk to you. Maybe you have a few more. Maybe you have like a search the web option that lets the model search the web and obtain information back. Maybe the search function has a query parameter, whereas the speak function might have text to speak and maybe another option of the name of the person that you want to speak it as. These are two functions with different parameter counts. But if the model is understanding the scenario in which you're using it in, it should be able to differentiate between the two functions and provide the function with the right parameters. This idea builds on top of language model translation because you have natural language which you cannot use in a program, but you're translating it into a language that a program can understand. The last piece that we wanted to go over, even though we really didn't use it in this research that we did, was discrimination. I say really didn't because we didn't focus on this piece. It would have been nicer to kind of implement more of it, but we didn't really implement it for anything crazy, and the entire use that we did use it for was fairly simple and straightforward. Discrimination, you could think of taking in input, maybe it's the context, or maybe it's a previous creation that the language model had. You give it certain criteria that you're trying to meet, and you're asking the language model to compare whether or not the provided information that you give it meets the criteria that you have. You could think of this as, here is a question that a language model created. And then the criteria might be, does the question make sense? Does the question pertain to the context of what it is that the student is trying to learn? Does it contain accurate information? Meaning, does it have any informational fallacies in it? Does it have any errors in creation? The idea behind this is you're having language models create objects that you use in a program. The discriminator is going to look at those objects or look at the data that your model is generating and accurately tell you whether or not it is correct or not, whether it is good or bad. And the whole idea with this is that you're going to use it to enforce certain criteria on the data that the model generates. The reason we want to do this is because we don't want to get caught up in bad generated data. If you think about if you're going to use this data in actual real-world scenarios where you're generating programs that are doing stuff, then having a model output garbage is not what you want to actually implement in a real-world scenario. We use discrimination because discrimination helps us differentiate good instances of objects and data between bad instances of objects and data. And this idea allows us to filter out the responses for things that we would actually want to provide whatever service or endpoint our data is going to. So all of that is nice, but what I want to do now is actually demonstrate how these things can be used in practice. Here we have a text document. I'm going to show the rendered version of this document just because it's easier to look at. But the raw version exists here. If you want to check it out, it is in the knowledge phase prompts. It is actually AI Tutor backend source, tutor utils prompts, and concept prompt. The visual representation is essentially this. What we're doing is we're trying to emulate an AI tutor. So we have a couple of components that we felt are really useful in terms of prompting. The first thing is actually the backstory. The backstory is something that is used in many other LLM acting papers or projects, such as the generative agents. And it works really well in a context where the outputs of the model are dependent on the backstory. A very good example of this would be if you're having a language model talk on behalf of whatever simulated personality that you want it to, giving the model a backstory will allow it to discuss and talk about the things and contain its outputs in the context of what it is that you're trying to allude it to. The second part of a prompt might contain some sort of documentation. The documentation is essentially there to guide the model to understand what it is that it's trying to do. Before I mentioned that you might have some functions that you might want the language model to call. The documentation would be where those function definitions are provided to the model. Granted, you don't need to have everything explicitly stated like this, but this kind of gives you a general idea of what the language model sees when it's making its predictions. So for right now, we're going to talk about the concept. The concept in our project was an idea or term or topic that we wanted to concretely and discreetly describe in a sense that we could use that information in other parts of our program. The concept contains 3 fields: a name, a definition, and a latex code. The name is just the name of the concept. The definition is a term which can reference other concepts. The idea of referencing other concepts might seem weird. Why might we want to do this? Well, I'll give you an example. Say you are learning about Newton's 3 laws. Okay, forget about physics. Let's talk about math. A derivative in terms of mathematics is the demonstration of how a function's output changes with respect to the input. Now, the idea of a derivative can be thought of in terms of the ideas of a function, the ideas of output, and the ideas of input. These ideas are what construct our data structure. In fact, we did a whole algorithm based on finding these references to other ideas and then using that to build out our knowledge graph. Now, in this text, we're giving it all sorts of information. We're telling it what exactly we're looking for, right? We're telling it, hey, we want principles and theories, we want processes and methods, we want systems and models, we want structures and frameworks, values and ethics, patterns and relationships, and so on and so on. The idea is that we are explicitly telling it what information to be paying attention to. We then define the process in which the language model is going to conduct. That is the concept generation process, where first you define the concept, right? This is thought of as the planning phase. Identify the related ideas by listing out a subset of concepts related to whatever concept you are currently trying to generate. Now, this is still the planning phase. And then finally, we get to define the YAML code for the given concept in the formats described above. Essentially, this is translation. And not only is this translation, this is planning and translation in the same prompt. Why does something like this work? And the reason is you could think of this similar to chain of thought, where previously we saw that if you reason through a task, then you could solve the task better and come to a better conclusion. In this case, what we're trying to come to is a valid conclusion, right? The translation of the concept name into the actual object representing the concept that we could use in our program. The planning of this concept requires that the model outputs information that will help it do the third step. Keep in mind, we only care about the third step, but the first two steps prepare it to do the third step. What does this actually look like? Now, we're going to get into the actual examples that we're giving the model to look at while it's doing it for our task. And these examples consist of a function, right? First, you define what a function is, you list out the related ideas, and then you output the YAML code. Same thing with input. You could see this for breadth first search, where we have an entire section for latex code, which we're telling it, hey, you could program for these concepts in latex. That way, later down the line, we could use that information. We're providing the model with information like Treaty of Versailles, where this is not necessarily a scientific or STEM-related topic, but we're still able to do the definition, we're still able to do related ideas, and we're still able to provide the YAML code. Okay, so now we've gotten to a part in which we've kind of engineered. This is a tiny part. I don't necessarily know how much of this other pieces have been implemented for, but here we're assessing the environment. We provide it with a framework to visualize and interpret what it is that we're giving it down here. And we'll come to this in a second, but just stick with me. For generating a concept, we give it access to a plan that the tutor has already created for itself. We give it access to the main concept. You could think of this as if I'm learning about derivatives and functions and changes and chain rule, the main concept for that would be calculus. The concept list is a set of items that the algorithm has already discovered. The reason why we provide it with that is because it makes it easier to perform mapping from one function to another. The note bank is the final piece, and the note bank is essentially notes that the tutor has taken. Granted, the tutor is a language model, and at this point, while we're doing this phase, you can understand that there's already other information being fed into it. And what does this information take the form of? Well, this is what we condition the language model on. You could think of this as the context, and this whole other section is what the context gives the language model or gives the task meaning to. Here we're defining how the language model should interact with our context and what the output should be like, and all of these extra additional things that we give it to interpret the information that we provided here. The idea with that is we could provide it with information and then condition its outputs on some arbitrary rules and guides and processes to get to our desired solution. You could see how we're embedding information into this prompt by using what I call delimiters in our prompts. The delimiter will serve as what we use to replace in the string that we provide to the model. The tutor planner will get replaced with whatever data is in the tutor planner at this point. Same with the main concept, same with the list, and same with the error. This error is any error that the model has encountered while doing the translation. Finally, we get to the task. And you could see that our task, in this case, follows the same format that we do here, right? And the idea with that is a really good language model will understand that it is now time for it to replicate what you previously shown it. And even though it hasn't seen the actual operation for whatever it is that you're asking it for, it should still be able to abstract out information from what you've provided it to perform the task that you're asking it to do. So I was thinking maybe we can continue this demonstration by converting software requirements into actual code. But I just kind of looked into it a little bit more, and I feel like that might be beyond the scope for today's episode of Prompt Engineering. So if you would be interested in something like that, feel free to reach out to me and we can talk about it. Today, I am going to do a little bit something different. So one of the things that would be really cool is if you had a way to kind of talk to somebody about just like animals. Why do I say animals? Because animals they're cool, you know? Like, animals are cool things. So how are we actually going to do this? Well, to start off, you could kind of download this code and continue with me, but I am going to go ahead and get started by implementing a Wikipedia search. To do this, I am just going to pip install Wikipedia and OpenAI and NumPy. If you were looking at that and making fun of me, I don't blame you. So after that all runs, then we're in business. So now we can quickly demonstrate how to actually use this. I'm going to get rid of this. I'm going to demonstrate how we could use our Wikipedia searcher to get data from Wikipedia for us. So we're going to get Wikipedia data for some topic, and the topic we're going to say and limit it just to animals. Obviously, if you're using this in your own projects, you could use this for anything. But real quickly, I'm just going to get the wiki data from topic, and I'm essentially going to say giraffe. Run this one first. Run this one, and you could see it returned a whole bunch of data. The title for this one is giraffe, and it has all of this content for me to deal with giraffes. Obviously, this is a lot of data, and we don't want to use all of this in our response for the user. So, building on the ideas that we came up with today, we can construct a sequence of actions. The sequence will be, it will take a user's animal question, the second thing we're going to do is find the best search query on Wikipedia. For the sake of time, we're just going to do one, but you could think of this as even being more powerful by having access to multiple Wikipedia searches at once, and then conditioning that search on a topic. The third thing that we're going to do is summarize Wikipedia article in terms of our search. And then the last thing we'll do is respond to the user. So the first thing we have to do is come up with a prompt for two, right? One is pretty easy. One is actually just some piece of the process. And they're all actually pieces of the process, but this is a piece of the process that doesn't involve us. The second thing, though, does, and we're going to have to find the best Wikipedia search for Wikipedia. So we're going to say wiki prompt is equal to this really long prompt. Real quickly, if you don't know about platform.openai.com/playground, then you can go to this website after logging in and copy some really basic template boilerplate code that we're going to use. Essentially, what this code is going to let us do is interact with this chat interface inside of a program. And the chat has also all of these models which we have access to use. Today we're going to use GPT 3.5 Turbo 16K specifically because of the really long context window. Once you've copied that code, come back here and paste it. And we're going to change this just a little bit. What we're going to do is we're going to wrap this in a function, and we're going to call it make LLM request. This is a very similar function that we have in our project, and we'll be implementing a version of it. And a lot of these things you could kind of wrap in other contexts, if that makes sense. And you can kind of use whatever you want to do this. I'm going to say model is equal to GPT 3.5 Turbo 16K. And it looks like they even had a new one there as well, 0613. I'm not really sure what that means, but it probably means it's slightly better than the last one, so hopefully we'll see. The other thing we need to do before we could actually use this function is define your OpenAI API key. I have done that already in my secrets, but you'll have to set it as an environment variable if you want to be able to use it. You could obtain an OpenAI API key from the OpenAI tab that we had open previously. You just have to go into OpenAI API keys and you'll have access to creating new ones here. Here we have our client. Our client is essentially our connection to the OpenAI API. OpenAI API. Say that a few times fast, you'll lose it. Our response is what we're going to use to actually return what it is that the model has came up with. The last piece of this function is going to have the response. We're going to add a few more variables, namely max tokens is equal to, I'm going to start off with this number, and we'll take that and move it there. I'm also going to change the temperature to 0.5. We don't want the model going too far off balance, so we're going to kind of turn down how much leniency it has with its predictions. We're going to update the model here. We're also going to add in a system instruction. The system instruction is going to help us accomplish whatever it is that we wanted to originally with the pipeline that we created here. So if you can see what we are trying to do, we're trying to use the language model as an animal guru. As an animal guru. Your job is to receive, input, and make educated decisions about what to do in relation to animals. I don't even like this. Okay, so here we've defined some context for the model to act in always. The next thing that we're going to do is inject the prompt, and we'll do that there. Now our actual interaction with the language model is configured. The next thing that we're going to do is actually write out the prompt that we're going to use to search Wikipedia. Okay, so by this point, we have a basic prompt that we'll go over. You are currently observing the query from a user and responding to them with data from Wikipedia. I'll get rid of the word currently because that would not make sense. Right now, you will be asked to search Wikipedia for animal information. How do you search Wikipedia? We have defined def search Wikipedia. Search query is a string. And then here we have our own implementation. But we need help calling our function. You will output the correct JSON to help us search Wikipedia. The output will be in terms of a search query, and then keep the search query short, as it will be used to look through titles of Wikipedia articles. Here is the chat history. Now you have observed the chat history. Output a search query in JSON format related to what our user is interested in. Here we have our output, and then you could see here I leave it blank. And the idea with that is that the model will infer to continue from that string there. I'll put only a output in JSON format. And what we could do with this is actually start doing some other things. So we're going to now define a chat equal to nothing, and we'll create a little function for this chat. So our chat will have a def chat interact, and this will take in no parameters, or it'll take in it'll take in data and a speaker. And then we're going to append into the chat the data. So if, I'll say user, and this is a bool. If user, I'll say chat.append I'll say tag is equal to else is equal to this chat.append tag plus data. In this tag will be like this: user else animal guru. Right, super simple. We'll make it so that everything's separated, and this should be enough to actually have a decent enough chat. The tag that we're going to use to actually interact with this prompt is the chat. We're going to import JSON, and we're also going to have a while loop here, just to kind of demonstrate how this would work. While true, we're going to say user is equal to input query. And then what we're going to do is take the query, embed it into the chat. So how does that look? We're going to say chat interact, and it'll be user query, and then the user will be true. And then what we'll do is we'll say our query is equal to our wiki prompt dot replace, and we're going to replace this chat with our user. Not with that. We'll actually replace the chat with the actual chat. So that'll just look like this, because the chat's going to be an array, but we're going to basically join the array into a bunch of question and answer formats. Now that we have this, what we can do is build on the query by getting the response from the model. How does that actually work? Well, we just need to make an LLM request with the query. And for right now, you could just print what this returns. So we could call this wiki response is equal to, and then we could just print wiki response. Okay, so let's run this. The first question that we'll say is, I love koalas. And it's going to give us search query koalas. What does a kangaroo look like? And you can see it's very simple. Nothing crazy up to this point, but we're going to build on top of this. We're going to take this response and convert it into a JSON object. So how do we do that? We're going to say, we're going to try, we'll have another while true loop here, and you'll see why in a second. We're going to try to translate that object into an actual object that we can execute into our program. So we'll say search query is equal to wiki JSON.load s wiki response. And then here, what we'll do is accept pass. We'll actually change this up a slight bit. We'll move this stuff out of the loop. So we'll do our user interaction outside, and we'll do our parsing in here. And we could probably do all of this outside of this loop. So you could think of this as obtaining the data. You could think of this as attempting translate, and here we are translating. The reason why we have this except block here is because we might not always get a good response from the language model, right? It's just a language model. It's just predicting text. We can't rely on the language model to make good predictions. And that includes, we can't rely on it to actually make these valid outputs, right? It just doesn't work like that. But what we can do is we could catch when it does output incorrectly and then continue to try to do it instead. The idea with this is that we could perform certain checks to make sure that our data is being processed correctly. So now what I'm going to do is I'm going to say search query is in search query. This will fail if it's not. But if we escape this loop here, right, this second while loop, then we will have a search query with the actual query. I hope that makes sense. So what we're going to do is we're going to take the search query and then call the get wiki data from topic. I don't want to scroll this. I want to come back down here. And here we're going to call the wiki data on the topic, and we'll say wiki data is equal to get wiki data from topic. So real quickly, I'm just going to say we can't have more than 16,000 tokens. So I'm actually going to restrict the amount of data that this wiki data has. So I'm going to say wiki data is equal to wiki data dot split, and we're going to split on the space. We're going to take the first 12,000 wiki datas, or wiki data points, and then we're going to dot join on it. So what does this actually look like? I will show you in 1 second, but we're going to take all of this. We're going to split on the space bar. We'll take the first 12,000 tokens, and then we'll join on the space bar. And that'll be our prompt. Now it's time to construct a new prompt. And I'll call this the summary prompt. Given the chat history, extract and summarize important data from the Wikidata data provided. Here we'll give it the chat. We'll also give it the Wikipedia data, and I'll call that wiki. Okay, so we have a new prompt that we're going to use. And this time, here's what we're going to do. We're going to take this same chat that we had here. We'll call it summary prompt. We're going to replace it on the chat, but this time we're also going to replace it on wiki. And we'll give it the wiki data. And we'll also make the response. I will call this the query response. And using this, we will print out I'll say kangaroos. I love koalas. Make sure we don't run into an error. It will normally take a few seconds. I figured out what the issue was. I was actually running this in an infinite while loop, and I was never breaking out. So now that it's not in an infinite while loop, let's give it a new shot. Okay, so it looks like it's now running. I'm going to give it some more information. I love kangaroos. It looks like it's stuck talking about koala. And I'm guessing the reason for that is because I said koalas. And it searched for koalas. I love the marsupial koala. It seems to only get koala. And this is something that you could fix in code. The code that I have running on this is not that good, as you could see. That's not really the whole idea with this. We're going to restart it just to make sure that it works. Kangaroos. Tell me about kangaroos. Okay, I see what's happening. I have to clear this chat history. So now we should be able to do this. So I love kangaroos. So now it finds kangaroo. And it says kangaroos are marsupials from the family of blah, 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 blah. Whole little summary about kangaroos. Awesome. Okay, the last thing we need to do is actually get it to respond. So we'll get the response prompt. This will say, provided a chat history and a Wikipedia summary, provide the user with a fun response. Ensure your be very simple. In fact, we actually have to modify this a little bit. Here we'll do the same thing. And this will let us just kind of copy and paste and just replace the prompt. So we're going to do this again. This time we're going to do response prompt. We'll get the response, and then we'll print the response as the animal guru. We'll also add it to the chat. We'll end that. We'll run this again. We will run this again as well. So we have a question. I'm going to say, I like hermit crabs. Well, wait. I should have commented some of these things out just because it's not necessary. So I will actually redo this because I don't want to see them. You can see it's here. Oh, hermit crabs are such fascinating creatures. Did you know that they are anorman decapod crustaceans of the superfamily Pagurdidae? I don't know this. They've adapted to occupy empty scavenge mussel shells to protect their fragile exoskeletons. There are over 800 species of hermit crabs, most of which possess an asymmetric abdomen concealed by a snug-fitted shell. These crabs have a strong association with their cell, which significantly influences the biology, blah, blah. Awesome! Okay, so you can see that we're not only given data from the user, but we're also taking that data and operating on it to produce a response. Now, you might think, well, can't ChatGPT already do this? Well, you would be correct. That's kind of why I wasn't too enthusiastic about this example. What I wanted to demonstrate, though, is that in this example, we are calling a function with specific information provided by the large language model. We then take that information and use it to develop a better understanding of how to respond. We then take the final consolidated information from the language model and from Wikipedia, which we obtained from a function in our program, to construct a response for the user. Now, before we actually finish here, I want to actually demonstrate one more fun piece. And that's going to be here. With fun stories. Your backstory is a alligator wrestler from the Everglades. You have also been on National Geographic with your own television series. Use this to construct quirky responses. And like we said, we're now conditioning the response to be in a certain way. I am going to ask it the same thing. I love hermit crabs. Not really asking. Well. If it isn't my little crustacean enthusiast, hermit crabs are quite the fascinating creatures, aren't they? Did you know that they have adapted to occupy empty scavenged mollusk shells to protect their fragile exoskeletons? It's like having their own portable home. Something about the Everglades. Just like me, after a long day of wrestling alligators and the alligators, I like to retreat to my cozy den. And you could see that just this one tiny line has influenced the way the language model responds, which is obvious, right? You're going to change the way something acts if you give it more information. And if that information is conditioning its responses, then you could use this to kind of tailor how something behaves. With that being said, what I want to kind of overview real quickly with this little tiny example is not the fact that we've built a little chatbot. The chatbot is cool. But the cooler thing for me is the actual execution of a code that we could verify runs in our program. You can see that this same response, right, the same thing about the shell, right, and their fragile exoskeletons must have came from that Wikipedia article, which tells me that if my interests lie in ensuring that the information provided in my program, on my website, in whatever it is that I'm building, is 100% factual, then we could use some online data source like Wikipedia. Granted, a lot of people say Wikipedia isn't 100% factual. I would say the contrary. I would say it's probably more factual than it's not. And it's probably more factual than most other sources out there that you could possibly pull from. And it's also really easy to pull data from Wikipedia, as we've demonstrated today. The idea is that you could construct these arbitrary prompts structures where you're feeding the output from one into the next to construct a bigger goal in the end. With that being said, just kind of food for thought, you could use this to kind of construct a whole slew of searches through Wikipedia. You could then use it to perform the discrimination which we were talking about before, which ranks the information in terms of relevance. You could then have it output the most relevant information based on that, essentially doing wide scan search. The goal of something like that would be to enable a program to have a large amount of information with a limited context window, and not necessarily having to depend upon the original context window since you're doing the search. You could think of this as kind of building the response before returning whatever it is. And as engineers, you can construct all sorts of arbitrary ways to do this. We demonstrated also that the objects are really easy to get to use right away. And in fact, it almost seems like it always works. It doesn't seem like it's failing at all, or else we probably would have seen an error message, which we haven't. And the idea with that is if you have a simple program that you're trying to run with a simple translation task, it should be very easy to get that working. Some of the more challenging ones include the ones that we take under and every day we're learning more about actually how to construct those prompts. These translations are very useful in actual running programs because, like I said, you could feed the output of a language model into the data structures of your program and then execute on them, which, if you've taken anything out of this lesson today, it would be that you could use language models to run programs. Everything else, take with as much creativity in mind, and I hope you all enjoy the new ability that you have unlocked in prompt engineering.